We are going to be drawing right now a staircase in Java. And in order to do that, we are going to be creating a method using the turtle class. And that method is going to take 3 parameters. So it's going to have the height and the width of each stair. And then it's also going to have the depth, which is all the diagonal lines. And you are fully able to customize each of those parameters, obviously. So you could have them all the same height if you wanted. In this case, obviously, it's a regular staircase, so they are descending very consistently. So the first thing we're going to do to achieve this is open our Turtle Java file. So you can see that we have public void drawStair. That's us calling our drawStair method. The public is the access modifier. It's one of 4 access modifiers between public, private, protected, and default. And then we're going to have the word void following, which means we don't expect any return. And then the name drawStair. You have to make sure that the name drawStair matches your file name as well that you're going to be using for your other file, which in this case it does. And then following public void drawStair, you're going to have your parameters, and you're going to specify the types. These are all just going to be simple integer parameters. So we have int height, int width, int depth. So now that is called our method header. And now we go into the method body, which is separated from the method header by, you can see, this bracket which I've highlighted, which you need to make sure that you have on both ends. So I broke this method up into 2 parts. For one, we're going to draw the rectangular base of each stair, and then we're going to draw the depth little offshoot, which you can see are all the diagonal lines. So basically, beginning with the rectangular base of each stair, this is just a series of forward and turn commands, except you're alternating between height and width every time you turn 90 degrees. And I went an extra side. Once I completed the rectangular base, I went ahead and coded an extra turn and an extra forward movement so that you are finished drawing the base and you end up at the top left. The reason I'm doing that is because the 3-dimensional aspect of this drawing happens at the top right, so naturally we want to start there. And then, so once we are positioned in the top left corner, we are turning 45 degrees and then moving diagonally. And since we are moving diagonally, you know that we're going to be working with the depth parameter. And we turn again afterwards, so then we'll be moving completely horizontally. Since we're moving horizontally, we are working with the width parameter. And then after those 2 turns and movements forward, we end up at the rightmost, topmost part of our of each stair. And from there, we still have to go diagonally back to reach the top right corner of the original base. And so to do that, we not only have to do, since we're facing right, we not only have to turn 90 degrees to face downward, but then we have to do an additional 45 degrees to make 135 to reach that top right corner of the base. So we turn 135 degrees. This is where we're at. And then we move forward using the depth parameter to complete that top slanted looking square part. So then once we finish that, we turn right back around and are just redrawing the same line, which is why you can see the turn is 180 degrees, to get back to the truly top and rightmost part of the whole stair, not just the rectangular base. And the reason we're doing that is because we still have to complete the right face of this rectangular cube. So we still have to go all the way down and then back to the rectangular base to finish the depth. So we once again have to turn 135 degrees to go downward. So we type in this dot turn 135, and then we do a forward movement to get to the very bottom of the stair. And as you can see, we're working with the height parameter. So with any of these movements, all diagonal movements are going to be depth, all horizontal movements are going to be width, all vertical movements are going to be height. So once we get to the bottom of that height command, we're going to complete the full height of the stair, the three-dimensional looking stair, by going that extra distance to get back to the original rectangular base. So we are going to turn another 45 degrees and go forward to complete the depth. And then once we finish that, we're going to hide our turtle so that we are just left with a stair. So that is the full drawStair method. So now that we have that, we are going to create our world, draw our turtles, and then invoke the method. And that's going to require some slightly careful setup in order for each stair to be perfectly next to each other and perfectly descending. So we're going to turn our attention to a separate file, the drawStair.java. And the first thing we're going to do is we are going to import our java.awt. This is going to let me color in each stair differently. I'm deciding to do a gradient from red to orange to yellow to like a lime green. And so the first thing we do after typing in the necessary line to access that infrastructure is typing in public class drawStair. Now this drawStair, of course, has to match your file name, which it does. And then we're making sure that we put public for the access parameter and class to follow that before typing in the name. After that, we write our line public static void main string args. And then once we do that, we can start creating our world, coloring the stairs, placing the stairs, and invoking our method. So we create a world W. I added just 10 to the width. Not super necessary, but I didn't want to cram in all the stairs. And then 600 for the height. I also created 7 colors, one for each stair. Since I mentioned they're a gradient from red to yellow, basically, with some green, you're going to see a high value of the R values, a varying value for the greens, and then 0 for basically all the blue. Once we have done that, we are creating the origin of each stair before invoking our method. So if you're building a staircase, physically you need them to be level, so for that purpose they all have the same Y value, which is 595. I placed it just above the bottom of the screen so that you could see the bottom line. So that's why it's 595 and not a full 600. We also want them to be the same exact width. So I spaced them out to be 90 apart. Actually 110 apart. And the way I did that was I just the total width of the world is 810, so I just divided by 7 and then gave a little bit of extra room so that you can see the width on the extra depth that stretches horizontally wouldn't get cut off on the world. I will say that if I were doing this again, I would try to write the code, write the width of each stair using like variables so that you could adjust the world length, the world width, and then automatically anytime you did that, the width of each stair would adjust. So I would like equate it to something like width divided by 7, which I've seen before, but and that kind of seems more similar to CSS than I had thought I would. It's more of a parallel to CSS than I thought I would see in using Java, unless I'm wrong and you can't do that. So yeah, that's the only thing after finishing this assignment that I would change if I were to do it again. But with that being said, we have our origin for each stair by creating 7 turtles, 1 for each stair. Because I mentioned they're 110 apart, we start the left one 5 into the world so you can see the lines, it's not cut off. And then we have it 595, which places it just at the bottom. And you situate it within our world, W. So that's what those 3 numbers mean. And then the only difference is we just add 110 to the first value each time. So now that we have set the origin for each stair, the only thing left to do is assign the color to each stair and then draw each stair. So since I made the 7 colors, which are target red, blood orange, orange artificial, orange organic, banana yellow, lime, and acid, the first thing we do for each method that we're invoking is set the color, and then we can invoke the method. So when we're invoking the method, the only change in the parameters now is still going to be the height. And so you can see we start at 555. That means that is going to be the tallest stair because it almost takes up the entire height of the world. And since the width is staying constant, we have that 110 value on all of them for the width. And the depth parameter also is consistent at 50. That was an arbitrary choice. It could be more. I just thought it seemed appropriate. And so after we invoke the method for our first stair, we do it yet again for our second stair, which we've already created. We set the color to a different one, and then we just make it about 90 shorter. And do the same with the next one, and the next one, and the next one, and the next one, until we have 7 pretty consistently descending stairs, which you can see in the image on your left. And we close with our final brackets, and that is the end of our invoking our method. So just to refresh, to recap what we already did, we created a method that intook 3 parameters, the height, the width, and the depth. And yeah, we wrote this method, and then we invoked it in the world we created with 7 different turtles. And we gave them all different colors. So I hope that was interesting. And that is where I'll end it. Thank you.